Our first talk is, in fact, a bit of a teaser to the next get-together, because it's all about mobile robotics applications not only today, but coming from a university perspective with a long-term view, also for the long-term future. And I'd now like to introduce our speaker. Since 2024, he's been, so this year in fact, since March, he's been a professor at the Technical University of Nürnberg. He's previously also lectured at the Technical University of Ingolstadt, and he specializes in mobile robotics, AI, automation, and human-robot interaction. His professorship is part of the High-Tech Agenda Bavaria initiative, and also this year he joined the organization committee of the RoboCup Federation for the class of search and rescue robots. Please give a warm welcome to Professor Dr. Christian Pfitzner from the Technical University of Nürnberg. Hi, Christian. Great to have you here. This is for you.
Yeah.
The stage is yours.
Thank you very much for the short and kind introduction, and I'm also very pleased to start this session today after the exhausting enabling of us all, a little bit breathtaking. As mentioned, I'm just Christian, no need for the professor or something else. I will show you a little bit of perspective on applications for mobile robots, and although those three applications or scenarios I present to you are not direct related to something like production or logistics, we conclude to that what we can benefit from if we do not only focus on the ideal setting in production and the ideal world we expect. Before we start, let me just lose some few words about the Technical University of Nürnberg. I'm not going to mention all those numbers. What you could enjoy in the meantime is this beautiful view with the Nürnberg Castle, if you have a little bit of time, half-an-hour drive. It looks like the university, the buildings in front are quite close to the Nürnberg Castle. To be honest, it's like 20 minutes walk, might be very steep. And yeah, to sum it up, we're probably in one of the three biggest universities of applied sciences in Bavaria, with a little bit less than 13,000 students. So we are close to November, so the numbers might drop a little bit at that moment due to some obvious reasons, especially in engineering, a little bit of foreign students. But I want to emphasize, we have a big focus on robotics. So this focus grows. That's also part of my professorship, which started this year. We have lots of colleagues in different departments. I myself are from the electrical engineering department. I have my new colleague, Professor Max Wagner, last year here as a speaker from Scheffler. This year he switched to the bright side of academia. And he's in the mechanical department, which is very nice because we did our PhD in the same department. Now we can work together, which is also quite good and really helpful in that thing. We as a University of Applied Sciences have a clear focus on education. Our product, what we deliver to industry, are good engineers. But we also get to have a much necessary focus to have on research. It's not only doing lectures. The universities of applied sciences have to do research, and therefore we get a new building which is only dedicated for research. So there are no lecture rooms included, although you could do lectures in that, but we have lots of laboratories, and lots of those laboratories are also related to robotics, which is very nice. In total, it's 110 researchers. It's in the western part of Nuremberg, where already is some industry like the Quelle or AEG, those buildings in the back, but it's a new build-up, set-up building. I have myself 2 laboratories for mobile robotics, which drive on the ground. You will always obviously also see some normal industrial arms and manipulators, and Max also has a laboratory, so that's the melting pot of robotics research associated. There are other laboratories. It's not only robotics with most of the part. And we have Europe's biggest test facility for flying robots and drones. And the funny part is I'm responsible for that because they built it. They said, yeah, we know, do you want to have it? And I said, maybe. Doesn't anybody else want it? I said, yeah, I take it. And nobody knew that it was the biggest drone facility in Europe. at that moment. So I did a little bit of research, and it's in fact the biggest one. I hope we can start in March 2025. I'm getting really sad if they mess up the construction site again and move the plan of starting in this building backwards. Mobile manipulators. What I'm going to show to you are not the typical applications you expect probably from production or logistics. The general purpose of a mobile manipulator, if you're not familiar with it, you have a mobile base. So you have an AGV, AMR, whatever you call it, and on top of that, you put another manipulator. That's the basic scenario. You can scale it in small, you can scale it big. There are some products available on the market, but to be honest, it's not that you have the same density compared to industrial manipulators. And you obviously have a battery-powered vehicle, so it's not attached to any power source like the classic industry robot, so you might also consider how you could move. And yeah, in a fenceless environment, you have high mobility. You can just drive to a certain area, do some manipulation, drive to another area, do another thing of manipulation. You could also use that to transport goods, but that's probably not the main purpose of a mobile manipulator. If human and robots share the same workspace, you obviously have a high demand of human-robot interaction and safety in that field. And obviously, it's preferred that the mobile base navigates autonomously between A and B. That's the course. It doesn't make sense that anybody does a teleoperating. I mean, you could also say mobile manipulator, putting it on a trolley and moving it to a certain workspace, but we are more ahead of that. And just compare it, 3 workstations on top, that's the classic scenario. If you have something, a production, you have a workplace or a workstation, you put a robot on it, and the robot does some kind of work. This is good. If you have a high load and you want to do multiple things at the same time, that's the scenario to go. But if you have a process where, for example, each workstation is only used once an hour or every 2 hours, like loading something into a machine, and this machine can work 2 hours on its own, it might be a good idea to switch to something like a mobile manipulator, where you have a robot which drives between those stations. That's the ideal world, or I suggest what you should use in that scenario. And the first scenario I'm going to present to you, because I was assigned for the organization committee of RoboCup Rescue Federation, is search and rescue. And that's not the typical use case, but maybe you have ideas of using a robot in a hazardous environment, then that might be an idea. And you can switch out the nuclear power plant with chemical factory, or what I also had a call 2 weeks ago about putting a robot into a high power transmission station where you cannot do any maintenance with a human because you have to shut down the whole facility. And if you put a human inside, then that's good to go. Some hazardous environment might be radioactive. This top left is the safest nuclear power plant in the world in Zwentendorf in Austria. It was built in the 70s, and also in the 70s it was put out of order. No nuclear material ever reached this reactor. The other funny naming of this is it's the most expensive Technik museum in the world. So you have a complete reactor in 3 weeks in advance of starting this or powering up this reactor, they put it down. But we do some training in that, and obviously you do not want to harm people if you bring them close to something like radioactive substances. We train in this facility by really putting radioactive material inside, finding it, do some mapping and navigation, and try to measure what kinds of radiates there. And obviously, it doesn't have to do everything. A robot doesn't have to do everything. Robot could also assist. And on the top right, bottom right, you see a bomb squad training where we also try to evaluate our robot in that scenario and compare it to human performance. This suit the guy has on weighs about 40 kilograms. He was active for 10 minutes, and compared to our morning exercise, he was really, really sweaty and exhausted after that. And that's the guy who has a tiny screwdriver to defuse some kind of bombs. Everybody's happy if a robot could do this with a little bit of an invest. Our robot we use for that scenario is Schrödi. Schrödi is, I think, 7 or 8 years old, so quite old at that moment. No Siemens PLC inside because it is quite tough to get any electronics inside. So basically, it's completely engineered by students or PhD students. Weighs about 80 kilograms, is obviously equipped with a manipulator of a 7-degree freedom for inspection, for tiny manipulation tasks, and has a high mobility. We can incline stairs with up to 50 degrees. So that's the normal staircase you have at home. That's probably like 35. And we have a mission time of 90 minutes. So that's also not very large, but in 90 minutes, if you have some inspection task, you should limit it to that. But it's also very tough to get additional batteries inside of that. Additionally, from a sensor perspective, we have lots of 2D lidars. We will equip it now this year with a 3D lidar. We do autonomously some mapping, so we get a really precise 3D map out of every environment, and we enter something like a nuclear power plant or this bomb diffusal site without any knowledge to it. We know it's a building, we know it has walls, and everything the robot does on its own by a little bit of an additional support by a human. So I'd like to say we always do everything autonomously. The ugly truth is no, most of the time. If there's really a training like the bomb squad, they want to have the full control over it. But due to some environment, like big concrete walls in a nuclear power plant, you have to consider doing a little bit of stuff autonomously, like driving from A to B, or inspection in that case. One scenario, one tiny application video, opening doors. If you have a mobile robot or you have a vacuum robot at home, a closed door is an obstacle. We could open that, and what you see in this scenario, how does, in that case, the operator open it? He only didn't use the arm, but he also uses also parts of the robot, like this, I call it flipper, the bottom right arm of the robot, to open the door. And the next research proposal is something like this, using reinforcement learning to automate this stuff and learning from the human behavior in that scenario. We could open this door, and this is quite heavy as it has a counterweight, so that's not like an easy door to open, in, I think, 40 seconds. That would be, I think, the record. In that field, we collaborate with the National Institute of Standard and Technology, shortly NIST, which is also responsible part of the organization of this RoboCup committee. We do a little bit of exchange with the Belgian bomb squad. They already use robots. They are massively related to military applications. The Belgian bomb squad is a military facility or department, and we also do some, I'm not going to say low-hanging fruits, but with the local fire brigade in Nürnberg, we have a little bit of a collaboration of evaluating what a robot should look like to be put into a house to search for people in that case. Some tiny events, the RoboCup Rescue will take once or two per year. And the World Championship is next year in Brazil. This year was in Eindhoven. We also participate in this European robotics hackathon, which takes part in Zwentendorf, the safest or most expensive Technik museum. And next year, we're probably going to Fukushima, set our robot there in a test facility and evaluate with the engineers of Fukushima who try to minimize the risk of any radiation exposure in the field of robotics or by the help of robotics. That's the search and rescue part. The next one is also not production related, but it's getting more healthy in that case. And Max mentioned if you have any health issues here, go to the back. Maybe there's a robot who could assist you in the future. And that's also a research project. And what we did is we looked in a surgery room. What's the classic setting? The minimum setting you have on people in a surgery room, you have a surgeon, you have the so-called surgical first assistants, both work in a sterile area, working close to the patient, and you have something like, it's called the circulating nurse. The circulating nurse doesn't have to be there all the time. That's someone who's checking, for example, 4 surgery rooms, hands over some tiny items like another pair of gloves, some tweezers, and tiny very items, so therefore it's okay to use or to inspect or to maintain 4 of those rooms at the same time. But what I didn't expect, and when I talked to the physicians, the surgicals, if some of those circulating nurses get sick, they really have to cancel some surgeries. So you have the surgeon, you have this first surgical assistance, but it also depends on those people. And therefore, we evaluated, can we use a mobile manipulator, not to replace, but replace is a bad word in that context, but to assist in that case of a scenario. Is it possible? And that's also the case. We do not have to be active with the robot all the time. Like retrieving some sterile items, changing the light settings of a medical device. You would also say why we don't use some Wi-Fi technology to change that. Yeah, the medical device industry is changing very slowly. So there's nothing like OPC-UA or MQTT included, perhaps also for safety reasons. After 3 years, that's the demo at a university hospital in Munich. That's a mobile manipulator. It's equipped with a Franca Emica Panda arm, which hands over, I think, some gloves in that case. So the robot also opens the sterile package, so there's no contamination. And it's also driving in that case. And as you've seen, we use a gesture to call the robot. We say, OK, I want to have another pair of gloves. It's directly connected of who's the surgeon in that case. And finally, it's reached over by a simple gesture, like raising a finger or raising your hand, so that everybody in the room knows, OK, the robot is moving now. Research consortium, Siemens, Healthcare, Franca Emica, EvoCort is my side, and the Technical University of Munich. Quite a success, was funded by the Bavarian Research Association. On the final application, I'm going to present to you another different thing, so leaving the hospital. But if you remember when you have been the last time in hospital, did you enjoy the food? Never. Never, no, really. My son was born 2 years ago. I don't know why hospitals have that type bad of food. If I'm a local hospital close to a city, I look for Lieferando and try to get up some pizza in that case. So maybe that's a little bit connected to that. The motivation here is you have a little bit of automation. For example, in a bakery, you have something like bread slicer, where you could set up, OK, I want to have my bread sliced. They push a button, you get your bread sliced. You can argue about the thickness. Please don't do this if you're in front of me at the bakery. I do not want to have 5 minutes of unnecessary expressions in the millimeter range. And you also have some high automated factories, like something baking cakes in an industrial or baking bread, which you can buy in a complete supermarket. But that's something like that. So those, I call it bake shops in the supermarket, where you can buy bread rolls and bread and some other pastries. And today it looks like this. There is no artisan educated baker at the back and trying to bake fresh bread rolls every 5 minutes. Here it's like someone from the register, a cashier, has to go to the back, fetch from the cold storage some bread rolls, put it on a baking tray, move it into the oven, 20 minutes later, come back. So this disturbs a little bit in that case, in that scenario. And that's not the ideal word. The bread rolls are frozen and then they are just baked. That's the scenario we have here. What we came up with is a robot baker. You also use a mobile manipulator. In that case, we use a omnidirectional base, so it can move all around. We put some Universal robots, I think 10E, who's the guy from Universal? There it is. And what we do is we have here those containers, those boxes. That's the standard industry, so it's just like a card box. This includes all of those bread rolls. We place them onto a baking sheet by doing a little bit of machine vision, a little bit of artificial intelligence, putting it into an oven and later on empty it in the bin. The robot is not that fast, as you see in one of the next videos. But we could start doing that at 3 a.m. in the morning, and we do not have to switch to that, and it's just necessary every half an hour to update it. You see here the scenario. That's a laboratory. That's not the newest video, but that thing I'm allowed to show to you. You have this container. You have to imagine that's the cold storage. At the back, you have those baking sheets. The robot fetches each bread roll on its own, so we do some image processing, a segmentation. If a bread roll is flipped up, we will also turn it. And this is the application the robot could do. To fill a baking tray, it takes about 1 minute 30, so the video obviously will speed up, as it should suggested. If you think why the camera is shaking, we used a drone for filming of that. I don't know why, but my research employee said, yeah, he has a drone, he wants to film it like that. And we could prepare something like a whole rack of bread rolls in that scenario. If, for example, we cannot reach all of those bread rolls because they are too close to a wall, we also have the strategic to shake the box a little bit. And in case the box is close to being empty and there might be a single bread roll, maybe a human could assist, but that's not always necessary in that case. It was funded by the Bavarian Ministry of Economic and Affairs, so it's still funding, with a project, that's not a funding volume, it's a project volume of 1.7 million. So that's quite impressive, and we collaborate really with one of the biggest kitchen, bakery, industrial manufacturer in the world, which is not quite common. It's not Siemens, it's not Bosch, but it's more in an industrial kitchen way of that. So those are the three applications. And what can you learn if you, for example, set up a robot into your production? And the first thing is, if you're good prepared for a disaster, it obviously also works in your production. The last time I set up an AMR and people said, yeah, our hallway is always clear. There is nothing standing around in the hallway. It took 10 minutes till somebody placed it in the middle of the hallway, and the robot, which was directly connected to a certain path, was blocked and started beeping. We know nothing. We do mapping. We do autonomous navigation. This is how we work. From the healthcare scenario, human-robot interaction is important. And also the safety-related thing is important, and that's essential. Just give people some kind of interaction to it, and just do not make it like a box driving around yourself. Try to get something like a communication. The raw robot also talks with you in a very narrow way, so it doesn't tell you stories, it doesn't give you the local weather forecast, but it's quite useful. And from the food and retail scenario, and this sums up maybe best way to why you should use mobile manipulators. If you have an application which doesn't need a high capacity, a high load of manipulation, but from time to time, or which you could also do in a very slower tempo, then why don't you use the slower tempo to make the process a little bit safer, a little bit more robust? And this is something which you could use also, not in these scenarios, but if you come to logistics production and use a local mobile manipulator, that's the way to go. Feel free to contact me anytime if this Ulm Innovation Center is finally started, I hope for March. We're also going to have a big party. That's something I hope, and I do not hope we get any budget cuts. Therefore, just sum it up with, thank you.
Thank you, Christian. Maybe one of the most relatable intros I've ever heard. Who enjoys hospital food? I will try to use that one more often. I think it always works, right? You're probably not the first time you've done that.
No, it always.
And you always get a laugh.
Yeah, so that was the purpose.
We have a few minutes left, so who has a question for Christian? If yes, just raise your hand, and we'll pass the microphone around. Oh, they're shy again.
That's the same thing I expect from my students.
Maybe, Christian, then I have one. So why don't we see more of these robots used in production today? What's stopping it?
It's not an easy topic. I mean, what you see is for example, the healthcare scenario. That's something we're might have a product with a range of 5 to 10 years, just roughly saying. It's not like we cannot get a funding for that if we have a product within 3 years. And it's not easy. We currently have issues getting mobile robots into a production, and now we add another complexity of putting a manipulator on top to it. It makes it more complicated. So what you're probably going to see is some highlight applications in a quite narrow field, in a small part of a production. And also, if it comes to human-robot interaction, sharing the same workspace, that's not too easy. Ever have a look on what the requirements are for a mobile platform, what kind of safety space you have to around it. That's not that easy. Also, there are some products on the market, but it's not comparable to the size of what you can get from industrial robots.
Mm-hmm. Okay. We have a question here at the back. Yes, thank you.
Good morning. Thanks for the nice presentation. One of the crucial questions I know with mobile platforms is the CE certification. So I would be really interested when it comes to this bakery application. How do you tackle that?
That's a tough thing, especially the bakery, and we are not sure if we can, for example, acquire any chance the same workspace with the robot, because placing the items from the cold storage onto the baking tray is totally fine, but we also handle up to 300 degrees Celsius baking sheet out from the oven, waving it a little bit around. So in that case, nobody can be close to that. That's also funny. If you have something like sharp materials in a production, everybody would say, okay, that's a total no-go. But look at every normal kitchen. You have sharp items in that case. And there's some competitor on the market who's currently collaborating with Fanuc. And they do not use a mobile platform. They use a linear platform between the cold storage and the oven. This works and this can be done, but that's completely enclosed in the robot fans at that moment. I'm not sure if it's possible, and therefore I would say it's more than 5 years to get it into a workspace without any human, and it's more than 10 years. I'm not sure ever possible if you could get a CE certification if you work in the same workspace as humans.
Okay. Maybe time for one more short one, if there is one. Doesn't seem to be the case. I'm sure, Christian, you're still going to be hanging around in the networking break, so in case any more questions arise, please feel free to get in contact with Christian. Okay, thank you so much. That was wonderful.